In this video, we shall discuss a different type of correlation, multiple correlation. We start with some variables w, x, y, z, etc. We want to know how well x is correlated with the others. Thus, on one hand, we have just x, and on the other hand, we have all the rest. How well is x related to these? Now, what do I mean by how well? We first need a precise mathematical definition for that. For this, we consider an arbitrary linear combination of all the other variables and find the correlation between x and that linear combination. The correlation, of course, depends on these arbitrary coefficients a, b, and c. If we vary them, the correlation might change. The maximum possible correlation obtained like this is called the multiple correlation between x and w, y, z. That is the definition. Now I am going to ask a puzzle based on it. Suppose that I tell you that correlation between x and 2w minus 3z, 3y plus z is minus 0.5. Now, do you think that this is going to be the maximum possible correlation that you can actually achieve between x and any linear combination with respect to ABC? So, minus 0.5 is the maximum, or do you see some obvious way of increasing the correlation further? No, it cannot be the maximum, because if correlation between x and 2w minus 3y plus z is minus 0.5, then just flip the signs here. Flip the signs in this part to get correlation between same x but minus 2 plus 3y minus z to be just minus of minus 0.5, which is plus 0.5, and that is bigger than your minus 0.5. From this, you should be able to see that multiple correlation can never be negative. It must always lie between 0 and 1. Due to its non-negative nature, we use the symbol r square for it. If we want to make the variables explicit, then we write something like r square x dot y z w. Notice how, unlike the partial correlation, here we have a single variable before the dot, and after the dot comes a list of all the other variables. Multiple correlation, as I have defined it, appears to be hard to compute. Actually, it isn't. The most correlated linear combination may be obtained by regressing x on the other variables. The resulting fit is the required linear combination. The correlation between the fit and the original variable gives the multiple correlation. All standard softwares can compute the regression, and so they can also compute the multiple regression as a direct byproduct. If all these confuse you, then don't worry. The next video will discuss how to compute various types of correlations in R. As you might have guessed, there are several mathematical identities that connect multiple and partial correlations. Before the advent of computers, people used to compute these correlations by hand, and such identities were extensively used to save labor. Now in the computer era, however, one hardly cares about these relations. If you are curious, you may click on the link given in the description box for one such list.